Hello, welcome to the webinar, A Picture Can Paint 1,000 Tests. In this webinar I'm going to show you some of the ways in which I do bulk testing and then visualize the output, and this webinar is to go with my tutorial at EuroSTAR called Bulk Testing and Visualization. EuroSTAR is a new conference from the people who bought you EuroSTAR, and it happens in London on the 27th and 28th of February. I'm on the group that put the program together. I think it's a good looking program, and I'd be delighted if you'd take a look at the program and consider coming to EuroSTAR. So, on with the work. Let's look at the subject that we're testing. It's a small algorithm. You can see it here. It's written in JavaScript. It's got one big clunky bit of maths, and then it's got a special case. And it exists to explore something called a power law relationship. Now, I can draw this out for you. It looks something like that. So it returns very large values very rarely, and very small values most of the rest of the time. The way this one's structured is it's generally going to give me 0, 1 in 10 times it'll give me 10, 1 in 100 times it'll give me 100, 1 in 1,000 times it'll give me 1,000. I give it a random number, give it more than 1, and it does stuff with that. I've written 5 tests for it, and you can see those 5 tests here. So I give it 0.1, round about here. It expects to return 0. Let's have a different colour pencil so you can see where I'm going with this. So this is a power law distribution. This is what my algorithm is going to go nothing for most of this bit, and it's going to give us 10 for that bit. But it's also going to give us 100 for that bit, and I can't draw it in much smaller. It's going to give us 1,000 for that bit. So that's what my algorithm's going to do. Now, this has some advantages to it. It's tiny algorithm, and it's got these 5 tests. But for the purposes of what we're doing here, it's nice because maybe it'll have some extra behaviours around the edges that I should be interested in, maybe not. Maybe I can explore what it does rather than my expectations of what it does by taking a lot of measurements and drawing a picture out of it, just from the picture you can see here. So let's have a look at my 5 basic tests. 5 basic tests, fewer, but my first basic one is at 0.1, about there, should return 0, and at 0.9, just for fun, around about there, should return 0 as well. And then we've got 10, well that's for this bit here, it's just before 0.1, and 100, at 0.09, that's just before 0.01, and so on. And I've got another one. Do I need all those tests? Probably not. I'm using a tool called Jasmine here. Jasmine is a unit testing tool for JavaScript. It's quite nice. One of the reasons I'm using it here is that it lets me put all my tests into one place. It's relatively easy to write, and I find it easy to demonstrate with it. Let's have a look at what the Jasmine script is doing. It's got a bunch of describe clauses at the moment. I'm only using one of them. And it's describing a basic test. I've got some text. It should return 0 for 0.1. I can put anything I like in there. And then it's got an expect. And it expects that when I process 0.1, I get 0. So I give something a number, I get a number back. And we go through it 5 times, and my results are over here. I'll just rerun that to show they are the current results. I'm hoping they stay the current results. So that's what this thing is doing, and this set of tests verifies and validates that. So that's all very well. Some of you will say those tests are too many, and others that they don't go far enough. I fall into the camp that says they don't go far enough. Let's have a look at some more tests that we might do with that. So let's have, looking back down into my helper function in Jasmine. Your helper function tends to go with each chunk of source code, and it contains a bunch of tests for that. Well, we've seen our 5 tests. Let's go deeper in. I've got a probe here. Now I'll need to comment out this stuff. Here I've got another describe clause. It's going to probe some invalid values, and it's going to try the values, and I hope you can see them here if I wave my mouse across it, of 0, 1, 2, -1, string and null, just chucking them in, and that's going to be given to a function called probe, which goes off and does something like that. So let's extend our confirmatory unit tests, and let's extend that with a probe. Now, the thing about my probe is that I'm not going to have any expectations for it. Let's run and see what happens. Save your file. Rerun that. Now this is CodeKit. It should rerun it for me automatically. That's not happening tonight. There we are. What JavaScript is telling what Jasmine is telling me now is that I've got a bunch of invalid values. I'm probing my invalid values. Remember, I want this algorithm to really only deal with 0 to 1s, what I want. So I want to know what it does outside those ranges, just in case I get some nasties. I can write some filters for it. Maybe I'll have to. Well, currently it returns 0 when I give it 1 and 0 when I give it 2. That's kind of all right. If it returns infinity if I give it 0, that's not unexpected, but it's not good either. It returns not a number when given -1, so it's not treating -1 as a number, but it returns not a number when given a string, that seems reasonable, and it returns infinity when given null, which strikes me as a particularly poor response. So now I know. And this isn't necessarily a check or a test, it's a probe, and I can give it as many of these values as I like. Those ones happen to be interesting to me at the moment, and it tells me what the actual behaviour of my algorithm is. I didn't know that before I ran the probe. I could probably have anticipated it, but my JavaScript isn't that good, and who, frankly, expects to give something a null value and to get infinity back when it gives you not a number if you give it -1? There we are. So that's this algorithm. Now I know a bit more about it. It's worth saying that this is not what Jasmine was intended for. But it's what I'm using it for, and I think it's interesting. So let's do something different with this. We've not drawn any pictures yet. I'm going to run in another set of tests. This is going to be even further than standard Jasmine. I'm going to use something kind of similar to what I might be actually using it for. And here, in this routine, I'm no longer using any its in Jasmine because its don't work for me. They don't return the information that I want in the way that I want it. So it's just a describe. It's an empty test as far as Jasmine is concerned. And in here I ask it for 30,000 of these values. I give 30,000 random values to it. It gives me a bunch of things back. Again, most of them are going to be 0. Quite a lot of them are going to be tens. There are going to be a few hundreds and maybe some bigger ones. Now, something to know. I've got a problem with the console because I can't put this into the browser window because Jasmine needs the various hooks in it to put something into a browser window, and I can't use it because I can't return values properly in it, or at least not big ones. And this is going to have 30,000 values because I want to draw a picture. So what I'm having to do is I'm going to log it to the console, but my console goes wrong at about 100. It truncates them. Wrong is the wrong word, it does it by design, but I don't want it to truncate my 30,000 results into 100 rows. So I'm using something where I'm taking my results, I'm putting them into a results array, and then I'm logging the results array to the console. I have to do a fiddle with the results array because I'd like to just log the whole array, but then it turns out I can't deal with the numbers. So what you'll see in my code is that I take the array and then I join it with \n, which is a return character. So that bit of fiddle is so that I can put something into the browser that I can then use later on. And I'm going to use it in data graph. Let's run it and see what happens. Run. There we go. So that's run. It's got the basic test. It probes invalid values. And it's got random sampling, and then random sampling doesn't tell me anything. Here, though, in the console, I've got a lot of rows of data. I'm scrolling down through it quite fast. That scroll bar's not going anywhere really. So we can copy all of that out by clicking there and hitting copy. And then I'll take this over to data graph. There's data graph. I'll paste it in. Now data graph has given me some fairly sensible column headings, but not brilliantly sensible ones. And I'm going to log, as it happens, the number sent on the x-axis, what I've got on the y-axis. And there we go. Well, that's kind of similar to the picture I drew before. Very difficult to read, though. It's difficult to read because, well, the largest number seems to be 10 times 10 to the 4. So that's obscuring everything else. Now, we can get round that by changing the way that data graph thinks about what it's doing. This graph is what's called linear axes. Let's change that. Let's change it so that it changes the y-axis to a logarithmic scale. Now that means that the first number will be 0, and the second number will be, let's say, 10. Third number will be 100. The fourth number will be 1,000. Instead of spacing by individual ones or tens or hundreds, I'm spacing by powers of 10. So the further up the y-axis I go, the more compressed my data is, which is fine, because that's going to happen. Let's have a look at what that looks like. And there I can see, okay, I've got something that sort of works. I've got stuff coming back. I've got 30,000 tests. Most of them seem to be coming back at 0. Quite a lot of them are coming back at 10. Fewer are coming back at 100. Fewer still at 1,000, and maybe that's just one at 10,000. Just for fun, let's change the x-axis as well. And now what I've got is I've got something that lets me see into each individual part. So I can see, yeah, genuinely, I've just got one value at 10 to the 5. I seem to have, what's that, 1, 2, 3, 4, 5, 6 values at 10 to the 4. Quite a lot more at 10 to the 3, quite a lot at 10 to the 2. So I've got an idea that I am at least getting fewer large values than I am small values, and that seems to be consistent as I go up. Something is raising my hackles though, because I've given this 30,000 opportunities, and so I'd expect to see maybe 30,000 and maybe 3 10,000. And I seem to be seeing 6 10,000s and 100,000. Bit curious. I can run that again. Let's run it again. We'll keep this same graph. We'll keep this same thing here. Okay, take this data back out again, copy. I'll paste it in up here. Alright, so how's my graph changed? Well, now I've got far fewer 10,000s. I've still got quite a lot of thousands. That's kind of what I expect. And remember, 30,000 is how many times I'm running 30,000 experiments. I get roughly 1 10,000 back for every 10,000 experiments. I've got 2 here. I had 6 last time. That's starting to seem more sane, having run it twice. Do it another time. There we are. There's my data. Copy it. Go over here. Paste it in. Didn't even need to delete it that time. Now I've seemed to have 4, maybe 5 in 10 to the 4 and 1 in 10 to the 5. I kind of see, yeah, that's feeling more reasonable than it did the first time round. So there we are. We've taken a tiny algorithm and we've expanded on some basic tests by going to the edges. We found out what the truth of what it might do at the edges is there. And then we've expanded further on that, and we've drawn graphs of, well, 3 sets of 30,000 is roughly 100,000-ish measurements of testing. We've got graphs of those, we've got an idea of what we're doing, we've also got a framework to let us change that. We've had a look at how manipulating the format of the graph, moving from linear to log forms on the axes, can change how we interact with our data. And that's it from me for now. I hope you find this useful. I'm currently travelling, so I think if you ask questions of me, then they'll be translated by Dara to me in the future on a telephone, who should be in now, who should be able to answer those questions, which one Dara will either be able to record me on the phone or will talk you through what I say. So I hope that is acceptable, and I hope you've enjoyed this webinar. Once again, my name is James Lindsay. I'm doing a tutorial at EuroSTAR on the 27th of February. And EuroSTAR itself runs 27th and 28th of February. The program looks great. It would be wonderful if you would have a look at the program and think, yeah, that looks like an excellent reason to spend a night in London and talk to lots of testers. I hope you found this useful. My name is James Lindsay. Goodbye.